cheap because it's non-functional, and I wanted to take a look inside, see what's doing, and see if I could possibly fix it. It's a microfiber blanket. It's very soft. I really like it, so it would be great if it could work, but might not. This is the type of blanket it is. I still can't say it. It's a Bidford. It's got 10 heat settings and a 10-hour auto switch off. So let's take a look inside. Okay, so opening it up, I see a couple of integrated chips. I see some diodes. I see some chip resistors. I see some bigger, what I'm assuming, let's see, they say M7 rectifying diodes for AC current. And let's see, let me try and read these guys, see what they are. This one we've got says LM339DC, which means that that is a comparator chip. And if I had to make my best estimate, it would be hooked up to the potentiometer dial to see what level it's at. This chip, it's a 14541BG, and that is a timer chip, which is probably linked to the 10-hour shut-off that it said it had. This chip here says VNF28AC. I'm not entirely sure what that is, but if I had to guess, I would say that it is another wave rectifier for the AC to DC power. And that's kind of all that I see on this side. We've got our chip resistors of varying sizes, we've got our diodes, it looks like this side is the side that's dealing with the AC to DC conversion, as well as the timer and the comparator chip. Okay, so there we've got the cover that came off, the little top for our potentiometer, the little hole for the LED on this side, and our little switch cover. There was a fuse right here, and I clipped it off to see what it was and to see its rating. And it's a 2 amp, 250 volt, which I would expect given the rating of the blanket itself. And I tested this fuse and it is blown, so that might be our only problem in this circuit, but usually fuses blow because something else went wrong. So even if I replace the fuse, this still might not work. But on to what we see here. It's a lot more simple on this side. We've got an LED, we've got our potentiometer, we've got some capacitors here of varying sizes, some resistors. Oh my goodness, these are huge. That's brown, black, gray, whatever mud colored this is, which is, we've got black, brown, red, orange, yellow, green, blue, purple, gray. That's 1 × 10⁹ ohms, so a giga ohm right here. Resistor, 2 of them. And this little guy right here, looking at where he's hooked up to, which is just the switch, he could be a debouncing capacitor, but he's probably more likely a PTC thermistor. So if these resistors get too hot, this guy will have a huge resistance and it'll stop the circuit. So probably for overheating purposes. Looks like we've got a little transistor right here. Our switch, of course, and a giant capacitor here. And that's basically it. It's pretty simple. There's no brains to the system unless you count the timer and the comparator. Looking at everything, I don't see any capacitors that are poofy or anything like that. Everything looks like it's functioning. I don't see like any burn marks on any of these things, so I'm going to say that maybe changing out the fuse will fix our circuit. But let's see. Like I said earlier, I pulled out this fuse and I tested it and it was not functional, so I figure I'll replace it. It's a 2 amp, 250 volt fuse, but when I went searching for it, I couldn't find something this size locally. So I went ahead and got a larger size, but same rating for the 2 amp, 250 volts. And I'm going to go ahead and put this one in, see if it works. Also, like I said, usually it's something else that trips the fuse. Not just a totally functional thing, but a power surge could have happened. It could have tripped the fuse and everything else is functional, so we'll see what switching it out does. I did look at the manual to see if anything else could be wrong, and it basically said if the light doesn't light up, return it to the manufacturer, which I didn't buy it from, so I cannot return it there. I do see that this is not an LED. It's actually like a little tube light, or a lamp as they call it on the PCB. I think that's really interesting. I'm only going to put 2 in because I'm not very confident that this is going to work. Okay. Now for the moment of truth. Safety first. There's no light. Unplug it back in. And unplug it and plug it back in. So the LED didn't light up, or I guess the tube light didn't light up, which is a good indicator that it's not functional, which isn't a surprise. Like I said, usually a different component will trip the fuse. So it doesn't surprise me that switching out the fuse didn't make it work. There's probably something else in here that's non-functional that needs to be switched, but no, it's getting warm. It really is getting warm. So it's just the tube light that's not working. Okay, so that's probably what tripped the fuse. And I don't care if the light in here is working, it's a functional heating blanket, and that makes me really, really happy. It's warm. It really wasn't functional before, though. I'm so excited! Hey guys, Sarah here. I picked up a blanket at my local thrift shop for very cheap because it's non-functional, and I wanted to take a look inside, see what's doing, and see if I could possibly fix it. It's a microfiber blanket. It's very soft. I really like it, so it would be great if it could work, but might not. This is the type of blanket it is. I still can't say it. It's a Bidford. It's got 10 heat settings and a 10-hour auto switch off. So let's take a look inside. Okay, so opening it up, I see a couple of integrated chips.